Let's now think about another risk, a sum of Bernoullis. This is known as a binomial distribution. Imagine that the risk could materialize or not, but for a set of homogeneous elements. For example, always within the category of environmental risks. Imagine that in the case of our mine, there are 12 permits to be requested. 12 environmental permits with regulatory requirements. This is also a transversal risk. We can model it with a binomial distribution. That is, we can take the first parameter of a binomial, which is n, the number of elements, in this case 12, because there are 12 regulatory processes that require the same probability of occurrence. The probability in this case is 20%, meaning that there's a 20% chance that the risk will materialize. That is, any of those 12 regulatory requirements will be denied. This is as if we were doing it together. Instead of having 12 Bernoulli distributions, we combine them and make a binomial. This binomial will be articulated as follows, as a binomial with n equals 12 and a probability of p equals 20%. In the cloud application, what we can see in this case is that we create a binomial distribution with n equals 12 and a 20% probability. This then articulates as a histogram with the different scenarios that could materialize. With each of these probabilities, the amounts of impact, cost, and monetary severity would be generated, which in this case would have a monetary impact with a minimum of 1,000, a most probable value of 3,000, and a maximum value of 10,000. By combining both elements, frequency with a binomial distribution with n equal 12 and p equals 20%, and a PERT distribution for the impact or severity, we obtain the convolved distribution of both impacts of this particular risk. Another example of the binomial distribution in contractual risks is related to conflicts or even insolvencies of suppliers or contractors. Imagine that in a project we have 35 suppliers or contractors. If we assume that each one of them has the same probability of having conflicts, let's say 20%, we can create a binomial distribution with n equals 35, the number of contractors, and p equals 20%, the probability of each one of them having conflicts. This will generate a probability distribution that will determine the number of conflicts that could occur probabilistically. Another example is the insolvency of suppliers or contractors. Suppose these same 35 contractors each have a 2% probability of going into insolvency. Let's imagine that in the history of this project or previous projects similar to these, on this project-based company, 1 out of every 50 contractors eventually goes bankrupt. 1 in 50 means 2% probability. If we have 35 contractors, the binomial distribution would model the number of contractors that might go bankrupt if these events occur with a binomial with n equals 35 and p equals 2%.